Hi, it's Gadget UK here again, back for part 2 of the Spitfire 2000. The way we left things in the previous video, I needed to test at 28 MHz and beyond. And there are a few other things we hadn't yet really tested thoroughly. So just picking up here by actually testing the RAM properly that we fitted in part 1. Right, so booting from floppy. And if we look at memory, we've got 8 meg. Let's test regions. Let's do the fast. Just leave that go for a few minutes. Yeah, and we did one pass, no problem, so I'm convinced the RAM is good. All good. Everything's good. It's incredible. I didn't think this was going to be this easy. And it wasn't easy. It was hard to build. But everything works. I'm just astonished that everything works. Yeah, I'm just in shock. I'm in shock that everything works. Because, well, you'd imagine with so many components on a board and everything being so small, it would be so easy to get so many different types of issues building a board like this. So many possibilities of getting shorts, especially on these things here, yeah, or pads not soldered on very well. And even on that Go Win, I'm just amazed that that worked first time, pretty much. So, yeah, we've got the switch, I'll show you that. I assembled that off camera. So it's just 3 wires going to that little PCB with a switch on it. I think it goes on 3 of the pins there. Like that. I mean, are you ever going to use that? Probably not. You might want to switch between your stock clock speed, because that's what that does. It goes between your 7 MHz or turbo. Defaulting it seems to be turbo on, which makes sense. There must be a pull up or pull down or something on that. So I need to test it alongside some other auto config devices. We've what's that active thing there? J12. Doesn't mention what J12 is. Might be an LED, so you can probably connect an LED to that and determine whether it's on turbo or not. The microSD slot is not supported just yet. Yeah, I think Live 2 could get to 28 MHz, and I don't seem to be able to. Did I test 28? Maybe I didn't test 28. Maybe I went straight to 33. I honestly can't remember. Let's try 28, which is just number 2 on. So if we take 4 off, let's see if 28 works. It'd be really nice if 28 worked. I mean, it's like I want my cake and I want to eat it. But this is the way us Amiga people are, isn't it? You don't just want some RAM, you want like half a gigabyte of RAM or something. Oh, it's booting. It's booting, I think. Oh my god, so it works at 28 MHz. So I'm in the same boat as Live 2 actually. So I'll just test the RAM out there. In fact, let's just boot from compact flash again. Let's take the disk out of the drive. Yep, that's booting up. I can hear it hitting the floppy drive. So, yeah, I'm a happy bunny indeed. 28 MHz. Haha. We'd obviously need to see how stable it is at this speed. I mean, based on the fact that nothing gets warm, I would imagine stability might be very good. So let's do speed. That should be now 28. I don't know why I missed 28 before. I seemed to jump straight to 33, didn't I? Hey, 28.4. Look at that now, 2904. It's fast. It's like 4 times faster than 2000, 5.4 times faster than the 500 or 600. 62% the way towards an Amiga 3000 speed. Bear in mind this benchmark's not very good. We're talking about a generic sort of speed here. It doesn't really cover all of the metrics of a system. Let's have a look at drive speed now. I'm curious to see how much that's gone up. We were 3.5 meg roughly before, weren't we? Haha, look at that, 4.6 roughly. 4.6 meg. That's nuts. Wow, what a cool accelerator for a 2000. Yeah, there we go, there's our Octagon ROM. Oh yeah, and we got 8 meg there. Yes, we got the 8 meg RAM and we got 64K there from the Octagon for the IDE. That is just such a sexy little board. That really is cool. And one thing that did strike me actually is the 5V supply to this board is crap. This thing here. We might be able to go faster if this was working properly. Let me just measure what the 5V is now somewhere on one of these 7.4 series down here. Because, yeah, I've talked about this so many times, and I had this problem with 4000 as well, but I resolved that on the 4000 in a way that means the 4000 is now really, really robust with a good voltage. See, 4.74 volts, yeah, 4.74 volts. Hang on a minute, just short the power supply out there somehow. 4.74 volts is not good enough, really. Hopefully I didn't cause any damage when I did that, like to one of these. Now it's booting again. So let's get some contact cleaner in there, and I'm going to try 33 again. Because there is a chance that, yeah, I doubt it, but anyway, things behave differently when you have, that pin there's red as well, that brown, that pin in the connector there's brown. I had the same problem with my 4000, which is what prompted me to do some stuff to the 4000 to solve that. And I'll just measure from one of the ground points down there to VCC, 4.89. So yeah, we'll just, it's still not brilliant, but we'll give it the next try at 33. Right, I have a keyboard connector, now going to test SF Flash. So we need a command line, and this utility was created by Live2. It predates his Ripple stuff, so you could do the same thing. It's got a Flash utility for the Ripple. So it's on storage, hang on. Yeah, the return key's not working very well on this keyboard. Which is an interesting one, because it's one of those new ones, you know, the ones with a new hard membrane, and it doesn't work very well. What's going on? So we've got a folder called SF Flash. Oh, I'm gonna have to try and fix that, aren't I? SF Flash. I don't know what the parameters are here. Let's just try erasing the chip. Let's do SF Flash -E should erase the chip, shouldn't it? Done. That was quick. It didn't take long to erase it, did it? So SF Flash -C -F. So let's do diag. Was it called diag ROM? .bin, I think it was. And then we need to select the bank, don't we? -0. Oh, what happened there? Only one of C or F can be specified. Let's press the other return. There we go. Flashing kick file, diagram.bin. So it erases it first, then it's writing it. I assume it's going to automatically verify. That's so cool. So I've also got Kickstart 3.2 there, which is fully licensed to me. So we could try, thanks to Stephen Leary, by the way, Kickstart 3.2. So we could try Kickstart 3.2 after this. I just want to see what happens now. Now, from what I understand, JP9, when you have the jumper set there, that's where it'll use the onboard flash rather than the Kickstart ROM on your motherboard. Yeah, so it's not the quickest process, that. But, I mean, I'm not being critical. I'm just saying it is what it is. That is so cool, though, being able to flash the ROM yourself. Because that puts a completely different spin on a product like this, doesn't it? It gives you so much flexibility here. You don't need to go and get a ROM chip. You can just use whatever ROM chip you've got that will boot up. I mean, granted, you need a Kickstart ROM that's going to work with whatever compact flash or IDE you've got set up. But that's so cool. So I'm going to find JP9 now. Yeah, so JP9 is there. And I'm not sure if it needs a mini jumper or a normal jumper, actually. I think it needs a normal jumper. Let's just get another one. I'm going to go with a different colour here. I'm going to go with red. Just because it's the sort of jumper you're going to want to, well, take it off and on. The other ones are just going to be sort of left in place, configured as it is. There we go. So JP9 is now set. So all being well, I'd like to think that should now boot diagram. So let's switch it on, see what happens. And it's not doing anything. One thought I did have here is I wonder if WinUAE, when I copied the binaries across, has done its thing where it converts it, byte swaps it for you, and it doesn't ask you, it just does it. That's the only thing I can think, is that Kickstart 3.2 and Diagram on there have been byte swapped automatically by WinUAE. Now, it does the opposite the other way around. If you copy files off a card like this in WinUAE to a PC, it puts underscore WinUAE or something built before it and changes it to a .rom or something. I guess one way to just test that functionality and the copy ROM to flash functionality is to do that, to copy the ROM to the flash, the Kickstart 3.1 in there, and we can remove the ROM physically from the board and test it that way, and that will just prove whether there's something weird going on with some translation of the endian. SF flash C, copy it, and we're going to do it to bank 1, the default one. So I guess if this works, yeah, it shows there is something weird going on with those files. WinUAE is too helpful for its own good sometimes, isn't it? It's like, I don't want it to byte swap anything. There might be a feature in there to disable that, you know, a setting or something in WinUAE. Right, so as soon as this verifies, I'm going to put JP9 on and see what happens. I think in theory you can leave the Kickstart ROM on there. I'm not sure whether it masks so that... I don't know how it actually accesses that ROM. It may be that this gets enabled on the board by Gary, I think it is, but this isn't looking at the board. It's the buffers isolate and it's looking at the local ROM. That might be what goes on for ROM reads when that JP9 is enabled. So let's get JP9 on. I'm just going to inspect that to make sure I haven't shorted to the wrong pins. Nope, JP9 is on. Let's try that. That's working. It's working. So yeah, WinUAE has done something weird to those binaries. We can prove that by, and it did boot there, you'll have to take my word for that, I'll show you though. If we just try and get this out. A flat blade is better, otherwise you make little round marks on these sockets, and it's so incredibly stiff, it's ridiculous. I haven't got the wrist strap on just now, just noticed. Right, let's just put that there. If it boots like that now, we know it's booting from Kickstart without an issue. Yes, I heard the floppy drive. It's booting. So yeah, that's WinUAE for you. That is really blooming annoying. Yeah, so we've got no Kickstart ROM on this board yet. We're booted. As you can see, there's no ROM. Right, I've worked it out, and a change of plan. Gonna leave Kickstart 3.1 as the default ROM there, I think. I'm not sure how you switch over yet, I still haven't discovered that. We'll work that out in a minute. If I now boot back up again, we'll leave the Kickstart ROM out and stick Diagrom in the bank 0. The reason it didn't work to start with is because I wasn't aware of this default bank, you know, the default boot bank of bank 1. So when I tried a few different ROMs in there, neither of them worked. Yeah, one of them was because it was byte swapped and one of them was written into the wrong bank. And in fact, now I think about it, yeah, we need to reflash anyway because I think Diagrom is not on there. Kickstart 3.2 byte swapped the wrong way is in the other half. What I'm not sure about is how you select bank 0. Well, you select it there to write it to bank 0. What I mean is, how do you actually boot from bank 0? That's the thing I am not sure about. Expected to see manufacturer ID of... Check that ROM overlay switched off. Oh right, okay. So it would seem there is one potential issue, that you've got to have it switched off before you flash it, which makes sense, doesn't it? Because I was wondering how is it going to access the ROM when it's actually flashing the ROM, if you see what I mean. So let's take the jumper off. It's just flown over there somewhere. Yeah, there we go. That is now erasing and writing to bank 0. So I just need to have a look at the card after this and see if there's some way to swap the boot ROM around. I don't know. It would be a bit strange, wouldn't it, to have two banks on it, but then not be able to select another bank. That's what I don't get. Yeah, so I'll ask if there's any way to change the ROM over. I can't find any way. So we've got it working with 3.1 in the default bank 1, which is what it always boots with. I can't go beyond 28 megahertz. That's as fast as I can get. Although Jorgan did say that he'd managed to get 42. I think Liv 2 got stuck at 28 or even 21, I'm not sure. So there's definitely some limitation there as to, depending on what motherboard revision you've got, etc. And maybe the components, I don't know. Maybe there's a relationship to the speed of the RAM. If the micro SD slot could be made to work, I think that would just be icing on the cake. But I mean, look at that, 4.8 meg. 4.8 meg on the IDE, that is just brilliant. The only way I can get IDE anywhere near that is with the TF536, and that is running at 50 megahertz on the 536, so he's got really, really nice IDE performance out of this. Just realised I've got 5 hard disk volumes there. Are they all showing up? I'm not sure they are. I'll count them when we go back to the desktop in a minute. Yeah, like that one. I know it is, SID. Yeah. I could have sworn there weren't that many icons. Anyway, look at that, nearly 4.9 meg. Let's just quit out of that and have a look to make sure all the icons are there. So we've got 1, 2, 3, 4, 5. Yeah, we've got them all. So, I mean, I'll try some games out now. Let's just try Frontier. It's interesting to test with a stock 68k, well I say stock 68k, standard 68k core, but faster, because you don't have any of the benefits of the 020, 030. Wow, already that's looking incredibly smooth and incredibly fast. That runs as fast as it does on a 50 megahertz 030. It makes you wonder what Achilles heel there might be on an 020 and 030 that 68k didn't have. Just on specific instructions or something. I don't know, there must be something that's different there. Because this is only running at 28 megahertz, and so far I would have thought that this was on a 536 or something running at 50. Even that there's super smooth. Yeah, perhaps marginally faster than that on an 030. You know, a bit smoother on an 030 on that little bit, but not much. There's not much in it. Ah, you can't do the quit. Yeah, there's me trying to press a key here. You need an MMU, so this might be where it would be advantageous to have a different CPU on there, just for WHD load, because we can't quit out. It's something like F10 or that asterisk will normally quit out. Because we don't have an MMU, you can't do that key press to quit out of a game in WHD load here. So we'll have to reboot it. Now I'm surprised at that. I'm surprised this more modern 68k doesn't have an MMU in. Yeah, I was just trying to pause it there and I died. Yeah, just testing some of this game. So this, oh god, I died again. This is supposed to need, really, ideally a 1200, and it runs absolutely flawlessly on this, just like it does on my 060 machines. Oh. Ah, it's swarmed. It's always the problem with this game, you lose all your power-ups. I wanted to get that power-up at the bottom. Yeah, anyway, it's really solid. And, as you'd expect, it runs really well. Oh, I'm so bad at that game. I didn't think the prelude would work. I thought it needed an 020 or greater, and it does. Wherever you see this 8000003, it's an unsupported opcode, I think. And that's just doing PRL check. The mixer came up with an error. Yeah, and I think on boot, when it was loading the mixer, it was saying it needs an 020 or greater. Yeah, so that won't work. I'm going to try booting next, the A2091. Mainly to disable some of the RAM from the card here, because obviously it's in the Zorro 2 area. Yeah, this thing is huge. Oh, hang on a minute, that bracket on the end is going to be a problem, isn't it? Oh, I really despise testing on the bench this way. Right, that's better. We are now raised off the bench with a box. It's the same box I used to use in the conservatory. I kept that box for this reason. Let's give that a try. Just going to leave it configured how it is at the moment, just to see what happens. You can hear it booting. It may have disabled the RAM on here, it may have disabled some or all of the RAM there, I don't know. Yeah, so we've got, yes, that's the prelude warning. Yeah, we've got 8 meg. We don't have any SCSI drives though, so that's an interesting one, isn't it? How have we got no SCSI? Let's have a look at boards. This might relate to that auto config jumper on the card. I suspect it does, to be fair. Although it picked up the prelude before, didn't it? So I don't know, that's a bit weird, that one. In that it didn't detect this at all. Why? Why did it not detect this? What's wrong with this? That makes no sense. I'm going to just try it with its stock CPU, which is nice because I can just pull that out and it's got the stock CPU. Let's just see if that works. Because that, there you go, it's booting. Yeah, that just gives me confidence that actually there's nothing wrong with the 2091. It might be an overlap on the drives. That might be why the drive. No, hang on a minute. Yeah, that would explain why the icons weren't appearing if they've got the same name and the same designations. But I don't think they do. I think they're called SDH or something on this one. But also, it didn't detect the card, did it? And what I mean is, in boards and sysinfo, it didn't report any boards. So that's weird. We know that it is looking at autoconfig because, well, it booted that way. But I mean, when this is in, it's not this jumper here, because it detected the prelude and it actually started to do some of the tests there. It just errored at the point where it was actually trying to do the, you know, send the sample to the crystal chip. So why would it not work alongside that? I mean, if we could half the RAM, we could half the RAM on this. Let me just find the 4 meg jumper, which is JP6. Yeah, so if I get that on, that'll change that to 4 meg. Maybe there's not enough address space, I don't know, maybe that's the issue there. So that's set to 4 meg. Oh, yeah, that's the right way around. Oh, God, I nearly had a seizure there. I thought I'd put this in the wrong way. Yeah, it's booting again, but it never looked at the SCSI again. Yeah, and again, we've got no 2091 report there, so that's fascinating. What would cause that? It doesn't like the 2091, does it? We could try moving it nearer. Let's try that. See, if it was working on boot, you'd start to see some flashing over there, and we're not seeing any. Yeah, if it's booting again from the IDE, but not looking at the 2091. Yeah, alongside the A2286 here from Amazing Chris Edwards, check out his channel. Links down below. It ain't working. The memory on this is set to 4 meg, so that ain't the issue. I'll try reseating it just for good measure, just in case it's to be fair, it's probably a 5 volt thing. Let's try that. Yeah, and the bridge board seems to work. This is the A2286. How cool is that? Slurring the words here with excitement. Yeah, set to CGA. So don't expect amazing performance here. I want to maximise that. I don't know why it's not larger. I think you can go full, can't you? You can click one of these here. No, you can't. It's not that one. Oh no, which one is it near? It's that one. That one maybe. No. Yeah, I don't think you can go larger than that. You might be able to. Is that frozen? No, it hasn't. We just can't see the bottom. I'm curious to see what the IDE tests out like here. Yeah, not especially fast from when I think back to the 2630. Hang on, is that where's benchmarks? I can't, what's this at the top there? Benchmarks is the next tab along. Benchmarks, hard disk. See? Yeah, I'm having to whack that return key still. 51.4, yeah, so it's slower than 536. And that makes sense because it can do twice as much, you know, it can transfer twice as much data at the same time, can't it, from the fast RAM. But I mean, it works. This is the thing here. and just test and see what works. I think Operation Wolf might be CGA, or it might support CGA. Let's try that. Bear in mind, you can't really play games using the emulated CGA here. It's, you know, OW, isn't it? In fact, I think that's set to, yeah, it's set to VGA. There we go, that's come up in CGA. Oh, you can choose it there. Best CGA. Keyboard. IBM. Well, that loaded alright. Oh my god. Maybe it is playable like that, I don't know. It's hard to believe. I would think the update, you know, rate here would be really, really slow. PC speaker sound. Well, it's actually scrolling. I didn't think that would be happening. I can move the cursor. Space seems to be the fire button. Well, call me impressed. I didn't think you'd be able to play games in CGA on this using the emulation. I want to say emulation, it's not, it's really hardware replication of CGA. But it's, you know, interface to the Amiga side. It's got to be, you know, so the Amiga's throwing all the stuff there into the relevant area of what would be VRAM on this to get these graphics working. I mean, it does actually seem to work though. That is incredible. So yeah, we've got compatibility with the bridge card. Don't know why the 2091 didn't work. That is a bit strange, isn't it? Like, why does this work but the 2091 didn't? I don't know what the grenade key is. Let's return. Doesn't like the Lift 2 card either. That's set to 4 meg. I'm trying it both positions on the jumper. While I'm here, I'm just going to take the opportunity and fit a 22 microfarad cap there. This was a prototype, and well, it just never had a cap fitted at the time. It doesn't really need it. It just struck me that, well, there's a space for one, and you know what I'm like. I see a space for a component, and every time I see that space, I'm like, I'm going to fit a cap there later, and I never remember. I never remember. And I think the only reason it didn't have a cap there is because, like I say, it was a proto, and at the time it wasn't that essential to have that there. But it's got space, so why not fit one? This is small enough to not obscure any of the slots that are nearby. Yeah, that cap is not going to make any difference, by the way. It's just something I felt like I needed to do. I'm addicted to fitting caps. And I really should put this through the ultrasonic because, well, I reflowed a bunch of things on this recently, didn't I? Unnecessarily, I might add. I forgot when it was now. It was testing something or other recently. A little bit of extra smoothing never did any harm. Anyway, let's just try that one more time. I might try and reseat this, but yeah, it never looks at the IDE at all. Yeah, it's just not looking at the IDE here. So, I don't know, it seems a bit sulky with cards that contain RAM maybe. So I guess we could try it alongside the AT Plus card. This just provides some IDE. Yeah, so I don't think that's working either. I think it's not working properly with Zorro stuff at the moment. You see that screen has come up, which is a good sign, isn't it? But yeah, it's not properly playing ball with auto-config or something. But we do know there's not like some fundamental problem with auto-config because the A2286 worked okay. Yeah, it just never looks at that at all. And just to prove a point, I'll just take this out and I'll just leave the stock CPU there. I do like the fact that I can just do that without having to mess around with CPUs. I'm watching the LED here. It's flashing. There you go. So stock CPU, there's no issue with Zorro. As soon as you get that in, yeah, there is. Yeah, so stock CPU works okay there. So, I don't know, maybe it's about speed. I mean, we could try reducing the speed on this. Maybe 28 megahertz is just a bit too fast for auto config. I'll set it back to 14, so we'll do 2 and 3 on. So we've reduced to 14 megahertz. Let's just see if that makes any difference whatsoever. Nope, nada. So I don't think it's about clock speed. I mean, I could try putting the switch on here, just and then switching it in the, you know, normal position. Let's try that. I don't know whether that's actually on or off at the moment in terms of the turbo, but no LED access whatsoever. So I'll switch it over to the other side. That'll just switch it to 7 megahertz, which means, well, ruling out the speed being an issue. And that's made no difference at all. It's not looking at the IDE. I mean, bear in mind there could be a timeout thing looking for the. Oh, hang on, it is looking for the IDE. Right, hang on. Got an error, Guru. Just click. Let's just see if that'll boot. Yeah, that's so slow. That is definitely stock CPU speed. We've got the RAM though. So it's not like you disable everything when you slow that down. You just, that's all you do, you slow it down when you've got that switch set to the normal speed, 7.09 or whatever it is. If you do speed here, that's just going to come back normal, isn't it? Yeah, 1.34, that's what you get when you've got some fast RAM. About 34% faster. And the cursor, there we go, 7.09. So if I click the boards, yeah, so we've now got 3 Octagon references, because we got the 4 meg that this accelerated card provides, 64k boot ROM, and then we've got 64k boot ROM on the AT bus card. But we're only running at the stock CPU speed there. Just switch this switch back, so that should be back in 14, and we'll just give it one more try. I'll leave it for a little bit longer in case it's taking ages to time out here. Yeah, that's booting. Maybe I just didn't give it long enough to time out. We are running at 14 megahertz at the moment, so I'll increase to 28 in a sec. Oh, it gave up. That's interesting. It was flashing for ages and ages and ages, and then just gave up. So yeah, it doesn't seem to coexist with Toro devices very well at the moment. I've never seen that before, where it flashes and flashes like it's actually booting, and then eventually we just get the sticky disc in the screen. Yeah, 28 never looks at it at all. So it does seem to be some sort of issue related to the, you know, as you go up the speed there, that's where you start to lose compatibility with the Zorro slots. And I guess that's the benefit of having the switch. You can just, you know, go to stock speed there, but if you can't use your Zorro cards, and it won't boot, that's the other thing, it won't boot when the Zorro cards are not working properly, in some instances from my testing here. That's a bit of a problem. The LAN IDE clock port, which you may or may not have seen yet, that works okay. I booted from that, which is really interesting, isn't it? So the only difference there is that's got a Xilinx chip on it. That other card we were dealing with a minute ago, the AT bus card, is using GALs. So it may well be that because it's got, you know, something that's slightly faster, tied to timing and stuff on it, that it's a bit better. Let's have a look at the drive speed on that, and we're running at 28 megahertz again, by the way. You're going to have the Zorro limitation there, yeah. Almost 2 meg. That's not bad, but that does work. I need to test it a bit more for reliability. Let's just do a speed check here, just make sure we are running at 28, but I'm sure we are. Can't test the LAN just now, or the clock port side of it, but I mean, I would imagine those are probably going to be alright. The fact that IDE's booting seems pretty solid here, and that's running at 28.4 megahertz, look. I can load TimeGal, let's do that. Yeah, that's working. So I'll leave that running for a few minutes and just see if there's any issues with that, but that's going to be continuously hitting the IDE. You can see the light flashing. Yeah, so that went around a few times, that demo. So yeah, I would think that that's actually a good combination. But it doesn't like Lift 2's RAM board, and it doesn't like the 2091, does it? Or the AT bus card. And I think for the final test I'm going to do here, test it with a Ripple. So you may or may not have seen this card yet as well. I mean, you don't really need it. This is the thing, it's IDE, but then again, it's a lot of additional IDE, which is nice. But you've got IDE. Yeah, I saw it flash there, so it did look at it. Flashed again. Yeah, so the ripple works as well. It might not be as fast as on the Spitfire itself. Yeah, look, just over 2 meg, 2.1 meg. But it is working. Again, I'll give it the time gal test. Right, so the next test is the POC 86. So here's the one I built in a previous video. Obviously we've got the one that came with this, which is incredible as well. This one I'd use some odds and ends. That socket there doesn't look so clever, but it's okay, it's functional. So I'll switch it off. We're going to need to use the E-clock generation here because I don't have a 68,000 on the bench. I mean, I could use the Pi Storm to produce that, but it's not going to, well, it's not going to be disabled because we haven't got the, I forgot what it's called now. Boss, that's right, Boss. We haven't got the Boss stuff going on here that you have on a 2000 that's provided by Buster to disable your primary CPU, you know, the onboard CPU that is. On the 2000, this, as I call it, the CPU slot here was really a co-processor slot. It was designed to make use of the Boss stuff so that the co-processor could disable this, but the two could in theory maybe work in tandem. I think there's an element of that with the 68030. I mean, it was never fully implemented that way to have two things running, be able to alternate with them in real time. But I think maybe that was the original intention. It just never came about that way. Because the 68030 cards, you know, the A2630, you can hold both mouse buttons down, or one, no, sorry, not both, one right mouse button down on boot, and you can choose which CPU you want, which shows there is intelligence there, being able to switch over using the Boss signal. But I guess, I kind of scratched it under there, I guess that could have been further utilised to be able to switch over in real time maybe, but anyway, so let's get this in, and it's going to be the same way, isn't it? Because it represents the standard CPU, you know, MMU co-processor slot. So in theory, it should work that way. And now I need to try and find what I've done with the SD card. Oh, it's here, compact flash card rather, not SD. And we need to set the E-clock jumper. So let me just take it back out again. Get the wrist strap on as well. I should have the wrist strap on while I was handling that. Yeah, wrist strap on. Yeah, E-clock is JP5. Yeah, so I'm going to put JP5 on, just because we don't have a CPU there. But even if we did, I don't think it'd work anyway, even though that would be producing the E-clock, they would clash because Boss is not implemented on a 500. Switch it on. And let's see what's happening. Yeah, I saw a flash there. It's nice, it lights up the Zorro slot when it flashes. Yeah, Amiga's boot so much quicker when you have a floppy connected. And I think you can get a floppy terminator just like you can the IDE terminators. That's really cool. And I think this is how Jorgan is intending this accelerator to be used. Even though it's aimed at the 2000, you can fit it in the 500. And when I say fit it in the 500, this is just to test it. But he's developed a right angle adapter that comes up like that, and then you can put it flat in the 500 here inside your case. It does of course mean this slot doesn't do anything unless there's a way to extend the slot out. I'll have to ask him about that. It would be nice if it had, as well as, you know, the right angle bit, as if it could have an edge like this, because then you could still maybe connect up an A590 or something. But do you really need an A590? You don't, do you? Or a Zorro card maybe, using something like the other one. I don't know what I've done with it now. Oh, here it is. Yeah, this one. Yeah. So we could fit that as well on a Zorro card. I may just try that in a second. Anyway, let's do a speed check. It's going to be the same, if not identical, to how it reported on the 2000, really. Yep, there you go, 5.48, dry stones 2903, 2840. The only difference here, we've got an ECS Agnes and we've got a Super Denise as well. So if we look at drives, slightly slower, 4545. No, it's about the same. It's not far off, is it? It's very, very similar. It's what you'd expect, really. And I'll put a picture up here of what he's actually intended to do there. And if we had one of those for this, and I might be able to get one, I don't know, then it would be ideal, really, to fit in a 500. You know, the IDE cable could be an issue, but you could flip this up, be a bit tight with that cable because that one's quite short, or fit a 90-degree one there, and then, you know, your compact flash is just going to come out over here somewhere. But it's potentially quite a nice upgrade for 500 because, well, you've got a lot of stuff on there, haven't you? You've got the ability to replace your ROM in flash ROM. You've got the IDE. The IDE is super fast. You can run seemingly a minimum of 28 megahertz. You might get more depending on your machine. In fact, let's retest that here. This might now give us a higher clock speed. So I'm going to go straight to 42 and see if that works. Right, let's train that at 42. Oh, it did actually hit the IDE. That's the first time I've seen it do that. So it seems less sulky on a 500 versus a 2000. It's looking at the IDE. This may actually boot. I mean, that'll be incredible if that works. But there's a custom firmware. He did say you need to experiment with the firmware because the IDE is so blooming fast. In fact, look, that's errored. Yeah, the IDE is potentially too fast now. But nevertheless, that is actually attempting to boot at that speed. That wasn't getting any IDE activity at all on the 2000. So the very fact that this is now, just reset it by the way, is now occasionally, there you go, looking at the IDE, shows there's actually hope to get it running at 42. Now he did sort of point me in the right direction, tell me which of the .v files to modify, you know, the source. But I don't have the development environment set up, and it would take some time to get up to speed with that, so that might be a follow-on video. I might do some tinkering. And that's the nice thing with this, is it's open source. He's open sourced it. Let's just see if we can get one stable boot. It'd be really nice to benchmark it. No, it's doing the same thing on a different file this time. C set patch 800003. It's like, I think that's some unrecognised opcode, isn't it? I think something's just going a bit too fast here, and it probably needs the wait states on that. What we might be able to do though is connect up an IDE, maybe the Ripple, yeah, in the slot here, boot from the Ripple, because then it's not overdriving the IDE, and it might actually boot up, and we might get a, you know, a useful 42 megahertz CPU. Let's try that. No, that's not booting. I think it may have crashed. Yeah, so that combination still isn't giving us a successful boot. Let's try power cycling it. I'll just reseat the compact flash card because sometimes that helps. That adapter is not the best in the world. Let's see if it works now. Yeah, that is not booting. Yeah, 33 megahertz did nothing. It never looked at the IDE at all. And I think that's the same I saw on the 2000, that when I put it to 42 I saw some activity just once. I could never get anything at 33, so it's like in between speed didn't work of 33. Anyway, it's working back at 28 again. At this point I thought it was a good idea just to test the CIA timers and the RAM on the 500. Yes, this is hours later. I've tested a lot of games on this. As you imagine, with the stock 68K, even though it's not quite stock, it is in terms of opcodes and things like that. It's solid, absolutely solid, and your performance is really good. I tested with an SD card here as well. Same as the compact flash, about 4.6, 4.7 meg per second when we're clocked at 28 megahertz. So yeah, this is incredible. And the interesting thing is I've just been testing it here for about an hour and a half, 2 hours, and I tested the felt chips here as I took it out, and they're stone cold, absolutely stone cold. You can hear the heater in here, so the air's warm, but these are absolutely stone cold after being on for, well, close to 2 hours. Yeah, I mean, why would you want an A590 when you've got this? I don't know. And I don't think the A570 would like it, if I'm honest. I might test it with the A570. Yeah, watch the A570 video for that. That's one of those coming up. We'll test it with that in that video, I think. Right, so I'm going to retest with the 3K resistor. Those have arrived. Interestingly enough, I got a free diode 1N4148. I'll put that with the others. It's always useful. So the resistors I put here, I can actually remove these. After part one, Jorgan sent me a message to let me know the type of VREG he sent me, and it provides, I think, a 4-point-something volt, 4.3 or something like that, volt to the FPGA, I think. But the type of regulator he sent me, you don't need these resistors. So I think that's the 3K, 302. That would be 2 zeros, wouldn't it? Yeah, that'd be 3K, I think. I'll measure that just to make sure. And that's the 1K2 approximately. Those can be removed, and I think he said C7 as well, so I'm going to remove that, and that. and we'll retest as well. I wanted to revisit this anyway, just to see if when we get a higher 5 volt level, can we go any faster than 28. And a quick overview of the board after doing all the work here. So I'll just have a scan around this. So we've got the new CPU there, jumpers. There's quite a lot of additional lighting there. It's just turn that lighting down a little bit. That's it. Yeah, so jumpers, still a bit of flux there. That's where we swapped that resistor out. Bodgy resistor there. Yeah, these were the hardest bits to solder, and I haven't got the focus just right here. I hated doing those little latches or whatever they are. Yeah, and it looks dirtier than it is. It's spotless because it's been through the ultrasonic. There's our Go-Win chip there. Let's have a look at the part number on that. Yeah, that print is really dim. It's hard to get a good angle on that with the lighting I've got here. Yeah, we went with the 010 there because that was big enough. Our SD or micro SD slot is on there, ready for some future update, maybe, hopefully. I think that's an activity LED for the IDE, maybe, and then you've got a jumper here, pin head here for LED as well. I'm not 100% sure about that. That could be to indicate the turbo is active, actually, but why it's a single connection, I don't know. Flash ROM, so that's where your kickstart goes. Yeah, that's 1 meg in size. And the additional bank there on a kickstart, I've worked that out through with Liv2's help. It's the extended ROM. So what you could do, and Matt suggested this himself, and that's maybe stick your kickstart 3.2 on there, and in the extended ROM, the upper bank there, or in fact it's actually the lower bank because it uses bank 1 as default, doesn't it? It flips them around. In that other bank, you could put some of the libraries that it needs, like icon lib and stuff, because that causes me no end of problems. So I might do that and build a 1 meg ROM effectively. Yeah, so if I look at those little buffers there, yeah, those weren't too bad. Same pitch as those latches or whatever they are on the other side, but those were far easier. And then of course our crystal, we've got good solder points all up the sides of that. Yeah, it's gone out of focus a little bit there, but yeah, very little on the underside other than 2 more RAM chips and the decoupling caps for those. And obviously our ID connector. Bit of flux in there, it needs a bit of a clean, doesn't it? Yeah, so you could argue maybe stick it back in the ultrasonic for a little bit, but I think you'll agree that looks really, really immaculate. I'm happy with the end result, and I'm happy with the performance of this board. It's a wonderful card. Right, that took ages to get working. It's been a while since I looked at this, and I had to go back down to 14. And then I tried to step up 28, it just wouldn't work at 28 after doing that modification of the voltage there. And I just got the idea, I thought, I wonder if we try faster speed, try 42, that wouldn't work either. And then I thought, I'll switch off, switch on straight away, and I did that, and it worked at 42, but look, it's bombed. But it's rebooted. So, hang on. Yeah, I think it's in a boot loop there, isn't it? So the other thing is, because this hasn't been used in a while, on the off chance that it's a connectivity thing, because connections oxidise, even though I remember cleaning up the contacts on that before I put that away. It's this board has been sat around for I don't know, 3 months or so, I think, since this was last used as 2000. Right, that's pretty darn clean, nothing coming off it. So let's plug it back in. Right, let's give that a go. So switching it on. Yep, you guessed it, I just plugged it in the wrong way. So something popped, I heard a pop noise. My hope is just the VREG has died and not something else. I felt it, nothing's hot. Yeah, we've got a dead short now between 5 volts in. Is that 3.3 short? Oh my god. It's probably killed it all. Yeah, I'm going to have to take off the voltage regulator to try and work out what's going on here, because I've now got a short between 5 volts and ground on this board. Oh joy. How did I do that? I unplugged it, cleaned up this, and then went, right, let's stick it back in, and I put it in that way around. Oh god. It's a hunt now, trying to work out what the faulty part is. I mean, the fact this short is on the 5 volt side tells you more or less what you need to know. That let's just see if there's a short on the 3.3. It tells us that it's on the side where the 5 volt stuff is. Well, what have you got on the 5 volt stuff? Caps and regulators, that's it. So, you know what, we might have looked out. Hang on a minute, the short's gone. How's the short gone? I haven't disconnected anything. I'm really confused. Let me try it the right way round. Briefly switch it on. Switch it off. I don't feel anything hot. Switch it off. I'm just going to try measuring voltages here. I'm going to try and measure the 3.3 if I can. Oh god, it's really difficult because, well, the angle will got to be out here. 3.3. Measure on the cap down here, which I'm guessing is going to be 4 point something. This is a huge problem because we have no clues at all, and it's now not doing anything. Something's wrong though. I'm sure I heard a little pop. Yeah, I think I've worked out the fault, or one of the faults. I think one of the chips here has gone. Let me show you. So I'm going to have to order some of those. I'll order 3 more. It's no telling what damage I've done to this now. Yeah, I think that's it. I think that's the damage. Yeah, can you see it's a lump? It's like a little lump. Little lump there. Yeah, a little lump. Real clear there. So I need to order one of those. That one seems alright. And that one seems alright. We did have a short on the 5 volts just for a few seconds and then it disappeared. I actually think whatever short has occurred here has just disappeared, and I think this is just like not in circuit anymore. You know, as it cooled down, I think it just became not a short. So I need to go and order one of those. Right, so I figure, let's get that off. And yeah, this may have saved something else. Something else may have died as well, but I think that's maybe saved something else. The thought here, what happens is, you know, when you get this around the wrong way, obviously, in fact you can see it here, here's the clue. Here's the clue. It's on the board. I don't even need to look at the pin out. Can you see here? You've got plus 12, plus 5, minus 5, plus 5, ground. Yeah? These connections here are lethal when you swap this way around. So what have we got here? We've got D0, D1, D2, D3, D4, ground. Well, the data bus is going to be buffered. It's going to be through this chip here because this is right next to these connections. Yeah, so it's a safe bet. That's probably the only fault. You can get more of a fault if things short across, you know, like 12 volts shorts from here across here, 12 volts into one of these things. But you know what? The protection in a device like this generally stops that from happening. You know, you have over voltage, and I think these have got under voltage protection. So well, I don't know. Fingers crossed. It could be a game over for this because you know what? I don't think I'm going to be able to get half the parts for this, not affordably, and I can't imagine I'm going to have hours and hours and hours of time to go and try and replace everything on it. It could be quite difficult to work out what's faulty, what's not. So anyway, let's just get some hot air, got some flux around it. I'm going to take this off. I've ordered some from DigiKey. That's it. Hopefully we've not damaged that. That took an incredible amount of heat to get off for such a small device. Yeah, the pins are alright. Yeah, I suddenly burnt my finger on the connection there, it's only on the edge. Anyway, let's just let that cool a little bit. Sometimes a fault like this can just help you learn not to make a fault, mistake like that again. But it can also, having a look at the connections there, you can see there about the voltages. The voltages are going to go into a pin. So if you had another card and did the same sort of thing, or were theorising that might have been done to a card, you know where to look. Even though there was not mark on that chip now, I would have a clue, because I'd be looking at those marks, looking at the pin out there and going, yeah, alright, voltage has gone into those pins. Well, sometimes you can look out 5 volts into a pin, not cause a problem, but 12 volts, yeah, the 12 volts is going to be what's done the damage here, I think. I actually think if we probed or scoped, measured resistance on the pin that's connected to 12 volts, we find that that's the short pin. It's another one of those funny things, my Discord, it curses me. Usually it's Live 2 usually says, guys, I've just done such a thing and something's died, and I'm like, nah, I've never seen that. And then it happens to me. And then what it was this week, it was someone else in Discord, I can't remember now, saying, oh no, connected something around the wrong way in a Zorro slot and it's killed something. And I think Live 2 was pointing out, oh, that'll have killed the CPLD, because I think he'd done it before. And I sat there thinking, I'm glad I haven't done those things that these other guys keep doing, sticking cards in the wrong way. How did you do that? And I put a comment, something funny along the lines, how on earth did you manage to do that? That's the most ridiculous thing ever. And here we are, I've done it. Not on the Zorro slot, on the CPU slot, MMU slot, call it what you will. Anyway, it's looking clean, pads are intact. Right, so just measuring on continuity. I think the top 2 pins up here are grounds. Let's just check. Are they? Yeah, they're not joined to each other. It cost me 40 quid this. Because there's a minimum order. If you get up to £30, then you get free shipping. When I say free shipping, it's like by the time you have tax, I got a £30 order. By the time you got tax, it's 40 quid. So you've got to spend roughly £40, £37 or something to get free shipping. And yeah, so I got some of those chips and I got some flux. What's this? This is a huge thing. Oh, that's the flux, isn't it? Yeah, it's quite a large tube, isn't it? I think that's the biggest tube of flux I've ever bought. I think that's the same stuff that Barry kindly, Sparks provided me in the past. That's huge, that. That is the biggest one of those I've got. And it worked out quite good. It was like, I don't know, £7 or £8 for that versus, crazy prices you'll pay elsewhere. So, DigiKey are really good. But anyway, we've got some new chips here. And I'm going to get one of those on. And I got some 7.4 series here for the Terrible Fire cards as well, because I've got a couple of those to build. And those were end of life. When I say end of life, they're not getting any more in. So I thought I'd better get some of those buffers while I can. The RAM is already end of life on the Terrible Fire boards. Can't even get the RAM anymore, so that's going to be an interesting challenge. Anyway, the pads were already cleaned up here. I'll put you on the microscope. We'll get that chip on. It might be alright with just that one chip, but is anything else on here directly connected to the data bus connections down here? If so, something else may have expired. But I just think that maybe the way that, and well, this is a testament to the design here, really, that if it works when this is on, if this is the only faults, it shows that it's really well buffered, that all of the connections through, for the data bus all go via these, which is kind of what you'd expect, because I think a lot of the things on here are 3.3. So that may have saved things, and this is the nice thing about using buffer chips in a design like this, not just to handle the logic level differences, but to protect the system. In any other kind of accelerator, if you got that round the wrong way, granted it'd be quite hard, because the older legacy ones, they stand out quite a long way. It'd be hard to get one of those the wrong way around. But when it's something the same size as the slot, it's really easy to get it the wrong way around if you're not paying attention there. How did I accidentally get it the wrong way around? I was just really, really, really unawake and unalert. It was like, I don't know, 9 o'clock in the morning, and I was like, a bowl in the China shop, and then I cleaned up the connections, put it in, tested it, and heard it straight away. After about 3 seconds, switched it off and thought, what was that popping noise? And then I noticed I put the card the wrong way. So you know what? It took no time to kill that IC. Like literally less than 3 seconds, and I heard the little small pop noise. And I'd heard that pop noise in the past and thought something's just burnt up somewhere. No smell, interestingly, which was a bit of a surprise, because usually when the magic smoke escapes from an IC, the first thing is that you can smell it and you see little fumes. But with this, it just silently, well, it wasn't silent, but it went and just popped, and that was it. Using the Antex this time. Right, that's that. So up here, yeah, they're not quite as low down as they should be, and we need to go marginally to the left, so I'm just going to heat and just try and move it a little bit like that. I think that's probably it, to be honest. That doesn't look too bad. So I should do the same thing on the other side, and then we'll give it a try. I'm praying to the retro gods here, the Commodore Amiga gods, if you're with me, please bless this card. Please let me recover from this mistake. Back of 2000, IDE to the right here. I honestly don't know how the hell I managed to get it the wrong way around, really. I jinxed it, but I was like, I can't believe this has gone so well, everything works, you know. I think I jinxed it. I'm going to put my finger on that transceiver. I don't think it's booting. Right, after a bit of tinkering, we've got it sort of booting, and I don't know whether it's using the new CPU or not. Well, I think it's the new CPU. I've got a jumper on the switch that switches it into its slowest clock speed. It still wasn't working. Then I thought, I wonder if the ROM... And then I started thinking, hang on a minute, this is 5 volt logic levels. I bet the data bus on the ROM is connected directly to the same place as that buffer. It's not going through the buffer. So I think the flash ROM's bugged. I think it's killed it. We'll check that by swapping it out, but we have got it booting, so IDE's just not working, and obviously I've got the eClock stuff disabled and everything here now, so all I did there to get that to boot finally was to disable this, because I was looking at this going, what are the likelihood of a data bus connection directly from here into that? No, it's going to be going through this. From that, maybe, but the fact that's now booting with this in, when this is disabled, tells me it's probably using that at 7.9 megahertz. So you know what? I think it killed the flash ROM as well. I think two things died. I think the buffer down there, and I think this. If we're lucky, nothing else. Right, here we are back at the bench. Yeah, I had this problem with this adapter again. You've got to get the chip not too far into the socket, and then put it in the thing, close the zip, and do that as you're closing the thing to make the legs, you know, make a fresh connection. So it's inconclusive. I couldn't get a read of it. I was able to erase it, but then when I did those things, it started to work all right. There we go. Let's try that. Let's see if that's any different. We've got the centre part, so maybe that's all right now. I honestly don't know. The next thing to do is to get the, if that works, get the compact flash. No, that's not working, is it? Unless it's just taking a while looking for the drive. I'm going to try and connect the drive up anyway. I mean, the logic is saying to me, maybe one of these transceivers is connected to that data bit down there where, you know, the few data bits where we had voltages going in. So, I'm thinking about this. Worst case is, maybe I can do some connectivity from down here, work out which of these is connected there. I'm going to disable the auto boot again. I'm going to take this jumper off here and just see, will it boot at 21 megahertz actually? I mean, there is a possibility that the Amiga got damaged from here, like the Zorro data buffers went at the same time. Yeah, that's booted. So it seems to be working at the faster clock speed. I'm now going to switch it to the next speed up, 28. So this is 28. I mean, I can see here the centre part, but there you go. So 28 seems to be working. I think I need to try and boot test kit, or, well, not really test kit, sysinfo maybe. Now, you may have been expecting me to connect Ghetto Drive up, but I've got this bodge fixed one here with a heatsink on there, so let's get that in. Hang on. What is going on here? Oh yeah, I deliberately closed that. And I did that so that the heads would be sat downwards instead of stretched downwards. So let's connect this up. Well, it's nice to know that floppy drive still works as well. Yeah, that's coming back alright. So we've certainly got the overclocking capabilities there, 28.4. I didn't notice whether we had RAM. Oh, it still doesn't show. We can see it here though, can't we? We can go to memory. Yeah, 8 meg fast. 1 meg chip. So it seems like the only issue we have just now is IDE. So why wouldn't IDE be working? This is the thing I need to get my head around now. Because you know what? They go through the same data connections. So what I mean is you've got data bus here, and you've got address bus. The IDE is just going to be data bus and address bus. I thought the flash was the issue, and that, well, we've reflashed it, yeah. That was with auto. Maybe auto boot was not disabled. Hang on. No, but then when it's off. Hang on, I'm confused now. Well, let's try with the drive on in case that's not disabled. Maybe I'm getting confused or something. But then why is it not boot when that's in the other position? This is the thing I'm having a hard time understanding. I'm thinking one of these. I'm thinking one of those is balked. But I was looking at the connections here that come in for the data bus, right? And there's no wires. They go straight to the chip there, yeah? And if I flip the board over, the only wires that are here go to data bits on the other side. So what I'm trying to explain here is it's not like the data bus comes to this, also from wires goes somewhere else, like up here. I don't think it does. I think these go through that. So unless something rippled through this, a short on the other side, which could affect everything on here, potentially killing one of those. I don't know, I'm finding it hard to understand. I'd need to go and look at the schematics next, I think, to see if there's anything drive related up here that may have a direct connection down here to the data bus. That's what I think I should do. But in any case, let's just plug that in and just see if anything different happens. IDE to the right, see what happens. I mean, to be honest, I haven't ruled out that flash run chip. Alright, it programs, but maybe there is an issue there. Maybe it's like glitchy or something. Wow, what a trauma that was. IDE. Hang on. Did flash a minute ago. Oh, it's flashing, it's booting. The ROM is sinking too far into that socket, despite the fact the base is glued in. That's not what you would expect, is it? Because you know what? Well, it doesn't make any sense at all. It's like... I can't honestly believe it. I spent quite a while looking at the schematics and stuff there, theorising, and I'm like, came to the conclusion, it doesn't make sense. That EEPROM, the EEPROM there, the flash ROM for the BIOS, IDE BIOS, its data connections and its address connections are all on the buffered 3.3 volt side. So I was like, how was the IDE not working? I was thinking, is it an auto config thing? I spent a while just testing this. I put the AT bus card into the 2000 on its own. That worked okay. So I'm like, well, it didn't kill the Zorro stuff. Anyway, it's working, it's working. I'm so relieved. So whatever you do, don't put one of these in the wrong way. You'll set yourself up for a failure like I've just done. So let's see, is it all working? It should be 28 megahertz, I think. We should have 8 meg. Yay! 28 megahertz. 5.49 times 3.03 MIPS. Let's do the drive speed. And the drives are back. That's the key thing here. Let's hope we get a decent performance here. Hey, 4.5 meg. Oh, I'm so relieved. I'm so relieved. That's what will happen generally if you fit one of these the wrong way around. I'm not sure how I'm going to remind myself to not make that mistake, because you know what? I was fully aware the IDE should be on the right, and I still did it. I still stuck it the other way around. Alright, the IDE wasn't connected at the time, so we got away lightly, but it's a testament to the design of properly buffering everything here, and that's what he's done. He's got those 3 large transceivers doing all the level translation and buffering pretty much everything. So you know what, that is an amazing thing. If he hadn't done that, I would have killed the FPGA on this. And of course anything else connected without a buffer there, you know, direct to that bus, would have killed it. In theory, it could have needed new RAM, new CPU, new flash ROMs, and well, all new chips and new, you know, a new FPGA. So it's amazing that he's designed it that way. I am so grateful that he designed it that way. Right. So for the record, I've never had to do this before. It could be a consequence of the chip I've used, but I've put a piece of chip carrier, you know, just some clear plastic cut to size on top of the base there. It's logical though that base may have made it stand up a bit further had it been still, you know, connected. But I'm trying to get it central here, not that it matters. Yeah, I've never had that before. I'm going to try and get the chip back in now. I think it's this one, I don't know, I had these chips all over the bench here. So the other thing I'm going to do here is just clean the sides of these, because you know what? I never cleaned them from the minute I got this chip. And this isn't the chip that came with the stuff from Jorgan and Matt. It's, let's say it's another chip that I had. Later, I may take this back out and try and get a light on there, because I think light should work. I'm interested to see if we get any, you know, additional performance boost using Liv2's IDE driver. Right, here we go. So let me carefully get that back in. So I actually think when I tried to dump this initially and I couldn't read it, I think that was all just a red herring, actually. Right, that's in. I think that was all a red herring, and it's just coincidental that, well, I had this issue trying to diagnose the card in general. Let's see if that'll boot now. IDE to the right. Yay, it's booting. There we go. So, isn't that strange though? Isn't that strange how we encountered this problem with that chip just as a result of the work we've done to fix that transceiver? That isn't what I thought at all. You know, you could easily go off at a tangent, as I start to do, thinking something killed the IDE. What killed the IDE? And actually, well, nothing killed the IDE. The IDE is alright, as you can see. So, yeah, very pleased. Right, I'm going to have a play around now. I'll test out some games and stuff on this. Woohoo! Yeah, and after that repair, I've tested every piece of functionality, including the E-clock gen. So yeah, I'll fit this back in there now. I did just clean the legs up on this with that cotton bud with deoxit. I thought, well, let's just use the bit of deoxit that was already on it. So clean those up. So I'll switch the E-clock stuff off. That's the jumper that's at the side here, right next to the clock speed jumpers. So this one wants to be off if you want a stock 68K to generate your E-clock. It's really easy to lose these jumpers, I noticed as well. You know, once you've been on off and on a few times, they start to get really loose on one pin. So a few times I've dropped one on the floor and lost it, and I had to go hunt for the blooming thing. Wow, that got a bit caught there. Anyway, let's try that. So that should be E-clock back, and it should boot with the 68K in. But I just thought I'd show you benchmarks here, AIBB, when we're running at 28 MHz. The memory in particular is what gives this card a bit of an edge over, you know, some different scenarios. So if I do a mem test, you'll see it comes out really fast for a stock 68K, because it's faster than 1200, the memory throughput, faster than 600 by a long shot, faster than a 4040. I'm not sure whether that means an 040. It could, yes, it probably does, because the 040 memory bottle, it's crippled, isn't it? Memory is crippled compared to an 030 in a, you know, in a 3000 run at 25 MHz, but that could mean the 4000 run at 40 MHz. That would make sense though, because you know what, I don't think with an 030 at 40 it should be faster than this. So yeah, I think that this means 040 here. So that's really good, isn't it? The memory throughput is incredible, and I'll do the same things we did at the slower clock speed, like a sieve and a saw and stuff. Yeah, there you go, faster than 1200, and it's on its way to an 030, not quite as fast, running at 25 MHz. I'm doing integer math, and that's come back a lot faster than 1200, look. And one thing that did cross my mind, because you can switch the clock speed in real time, I could in theory set this 33 or 44, boot it up until, you know, on the slower clock speed, switched off, wait until it's a bit stable, it's had time to warm up, and then try switching over to 33 and see what happens. So I might try that next, actually, just go up from 28 to 33 and see if that warming it up first approach and switching this over has any bearing. And again, I experimented with different configurations, so you can see I removed the onboard ROM and using the kickstart that's, you know, flashed onto it earlier, and that works. And I tried setting it to 33. Oh, we've got some video issues there. Let me show you that. Don't know. So, something's not happy there. Look, some variation on colours. Is it that hybrid? So yeah, just pressing down on the Super Denise. Hang on. Yeah, a bit of oxidisation on Super Denise connections, I think. It's just about voltage levels. You know, you get a voltage drop. I don't know that I've covered this. I think I have on another video. You get problems not just with video, but your mouse stops working properly as well. It glitches when you've got low 5 volts on a 500 with a Super Denise. You don't seem to get that with the Denise. It's like there's something more sulky about a Super Denise with low 5 volt versus Denise with low 5 volts. I'm sure they behave very similarly, but anyway, there is a difference there that I've noticed. Yeah, so I exhausted all the options there. We tested without the kickstart there. I tried disabling the IDE. That's what's the situation at the moment. The IDE is disabled, and at 33 it does boot and then freezes on the scrolling, you know, the disc up the screen bit. So it's a wee bit better when the IDE is disabled. So the following day, and a fresh attempt to try and merge ROMs, I spent a couple of hours last night messing around with ROMs. I couldn't quite work out whether it was a 32k ROM, 16k ROM, 64k ROMs or whatever on the combined image that was up to 512k, and I didn't know where they'd been joined. You know, like, was it, you know, 256k worth of the first ROM merged with 256k worth of the second ROM, or was it like a 16k and a 16k, a 16k, a 16k, you know, repeated that same pattern, like 1 2 1 2 1 2 all the way through, etc. And eventually I just got cheesed off with it because I was getting nowhere, and I dropped Jorgan a message, and he just said, 32k, 64k ROM in total, 232k ROMs. And he pointed me towards his original 64k ROM image that was merged, and said, just cut that in half. So I did that, and I wrote this to a new chip, 27C010, which is 128k. I just figured, the one that's in there, there's an issue, I'll explain. When I merged the two ROMs together, I couldn't write that to the chip. It was 512k, just the same as the other one exactly. And when it got about halfway through, just into the second half, the third address along from the second half, it would say, you've got a difference, you've got 03 instead of 01 or something. And it doesn't matter what I did, I just couldn't get it to write at all. I put a different chip in, another 040, and it programmed alright. So the chip that's on there, and this is something you may have experienced yourself if you haven't, you can get problems where you can get issues writing one particular bit, one location. So depending on the contents of that location will determine whether you can actually use the chip or not. Does that make sense? So the chip I think I've got on there now, it works with the original 512k ROM image. I was able to write that back so many times without issue. But what I can't do is write the new combined image. So anyway, this is why I've gone down to an 010 chip, which is 128k, and I've literally just got 2 copies of the same thing. In other words, I've got trying to think now. Yeah, I've got 32k of Octopussy, 32k of Lied. That whole thing's repeated a second time to give me 128k. Or is it 64k? I'm confused now. Hang on. 32, 64. Yeah, 128k. So we got 2 copies of each on a 128k chip, which I have just programmed up. It makes more sense to use an 010 if you can find them, but you see, the reason the parts, the bill of materials specifies an 040 is try and find an 010 chip these days. And you can probably just about still buy the 040 chips at 512k in size. The other interesting thing I found is this issue with this socket where I had to stick this little bit of plastic underneath it. I'm having exactly the same thing with this socket with any chip. Yeah, it's like the way these have been designed, they don't always work very well with these flash chips. You push the flash chip right into the bottom and it doesn't work, even though the base has never come out of that. So yeah, just be warned, you may need to put like a little shim underneath like I did with this one here. The question is, do we have Octopussy? Hopefully we do, because the Octagon was, issues for me. It couldn't see all my drives, could it? So I figure I'm probably never going to use Octagon, and I think Octagon might be aimed at Kickstart 1.3 compatibility. I could be wrong. Post in the comments down below if you know. Right, let's check this. So, very nice performance already. The key here, though, is... let's just have a look here. If we swap the jumper over... Hang on, is that Lied? That's Lied. There we go, so Lied is not really any different. We're getting the same sort of performance with Lied. I'm pleased, though, because we know Lied's working there. You'd expect the bank swapping here to be done on the 64k boundary, according to what Jorgan was saying, I think. So 128k should not be an issue. You should be able to use that. So in other words, you could use a 27C010, like I'm using here now, a 27C020, or a 27C040. I'm not sure you can get a 27C080. You might be able to, but it might be a larger chip with more pins, I don't know. And I was quite meticulous checking out looking for as you scroll through with the hex editor, looking for the text fairly early on in the first 2 or 3k to determine which ROM it was that I was looking at. I'm not sure whether you can see it in here. Ah, it's that there. That's a clue. Soft SCSI. It's in there, but both of them have got the soft SCSI thing merged in, the Octopussy and the Octagon. The key here, though, is it shouldn't say Lied.device. It should say SCSI.device, I think. So it's not really any different to Lied, is it? I suspect the same modification may have done to this ROM that's been done to Lied, but Live 2, I think that's the latest version of Lied I've got on there, by the way, and I think Live 2's done a number of different tweaks and things, so anyway, I've got to switch it back to use Lied. Cinemaware created some amazing titles back then, didn't they?
Unchanged for millions of years, yet witness to a biblical prophecy come true that one day the meek shall inherit the earth.
Just playing a bit of Cruise for a Corpse here. I remember playing this on the PC first of all, but it was around the time I had the PC and the Amiga. Yeah, I really want to try and get into this game. It's quite a cool game. It's made by the same company that did Another World, I think. Delphine Software, is it? Or Delphine Software, actually. French company, I think. Yeah, there's something very cinematic about their games, and of course they used sort of flat shaded polygons to create 3D type, models and things. Usually sort of drawn on a 2D background. Hang on a minute, I'm not sure I'm doing this right here. Seems to have worked. I remember playing this on the ST actually, using the MIDI. It's one of the games that supports MIDI. Yeah, cool intro, let's just skip that. Tomorrow morning. So yeah, some nice effects as well. So it's point and click, kind of like, Sam and Max, Day of the Tentacle, Monkey Island, Fate of Atlantis, etc. And this is the thing I always get on these games, like, is the multiple drawers there? Can you open the middle drawer? Yeah, you can. And what about the bottom drawer? Yep, that's quite cool, isn't it? There's obviously something in that drawer, because, hang on, I think it was taking ages to open them. Not very interesting. Need pliers, there we go, so there's our first puzzle. We need to find some pliers. I mean, why we would need to open that box and get the contents of it, I don't know. On the next screen we've got some music, that's quite cool. And here's one that often gets overlooked actually when I've looked at things like this in the past. I know the channel as well. Formula 1 Grand Prix. This was one of the amazing 3D racing games at the time. It'd be interesting to see if we can play this game, easily enough, you know, is it nice and smooth or not? I don't know what's going on. I think I need a joystick, don't I? What's interesting is the mouse did seem to do something. You can go up through the other cars there, look at the other cars. I'm still sat on the start line here, hang on. Sat, not start. But you know what, that's running really well, isn't it? I actually suspect that extra CPU power is benefiting us there. Not as much as it would with an 030 or an 020. You'd really need to compare it side by side a stock 68k, because I'll bet there's not much in it really. And the reason being is, well, if the game's running from fast RAM, it's a different story. It could run a lot better. But anything to do with graphics, interactions and sounds, it's all got to go through chip RAM, which is still going to be on the 7.09 megahertz clock domain. You know, you can overclock some of that stuff, but you run into problems when you start doing that if you're not careful. You can put your chipset at risk of failure. So all of these mods generally work by, you know, keeping the Amiga chipset on its 7.09 clock domain, and then your CPU with your fast RAM running at the higher clock domain. It runs really well, doesn't it? Let's just go through some of the other cars. Nice overtake there. Just a couple of the benchmarks there at 28 megahertz. This was right pixel, and I didn't expect there to be any difference here, but look, it is like twice as fast as a 600 doing right pixel, which is just not what I expected at all. Let's do TG text again. I wouldn't really expect that to be much faster. Yeah, so there's even there is a performance boost versus stock 500/600. We can try Matrix. Yeah, that's faster than 1200. Look. MU test, and we'll try the Eclipse test as well. I think the stuff on the right hand side of that benchmark that's in yellow, I think that's all stuff where it would use a floating point unit, you know, an FPU. Again, look at that, that's quite a lot faster than 1200 there. We're approaching 3000 030 run at 25, so that's quite good. Let's do the Eclipse. So yeah, I mean, it's not quite double. If it was double, it'd be like up here where the 1200 is, but it's not that far off, is it? I think that's all of those done. Did we do a dry stone? Let's do that anyway. I don't want people thinking I'm just cherry picking the things that make it look good. Well, all of these here, it comes out really well. I could do those two, a line test and an instruction test. Yeah, there we go. So that's not much. Look, there's not much in it there. But it's faster than a 3025, look. Go figure. I don't know. That's bizarre, isn't it? It is a bit faster though than both those things. Not as fast as a 1200 or a 4000. And the flops, all this stuff here, like I say, is floating point stuff, so I just don't see any point. I mean, we could try a basic one, we could try flops. It's not going to do very well there. Marginally faster than 500, 600 maybe. I mean, it's still doing integer division now I think about it, and some register to register stuff, so there might still be some benefit there. But you would notice massive difference in performance if you had an FPU. Yeah, so there's definitely a benefit even in the floating point operation stuff. You know, without an FPU, that is, because we've just got higher clock speed. So anything where it's, you know, it's using integer math to try and simulate floating point stuff. And Sorokin 2's working fine. So for the moment, that kind of brings us to the end of part 2. There may be a part 3, I don't know. Liv2 pointed out in my Discord that he might have a go at trying to get this working and help Jorgan with the code there. And apologies from previous videos where I said J. Bilander. It's not, it's J. Bilander, Jorgan Bilander. And I'm sorry if I've mispronounced your name there. I noticed I spelt it wrong. I put an E, I think, instead of, or an A, instead of an E, in the annotations, you know, the credits and things at the end. So I apologise for that. I'll get that right this time in this video. A huge thanks, though, both to Liv2 and Jorgan for creating this, for sending me the parts. Obviously, it's Jorgan that created it, but it was Liv2 that sent me this off kindly, but some of the parts and the board were provided by Jorgan. So huge thanks to you guys. You're both amazing. You create amazing products like this. Both of you work together on some of these things, and it's just amazing what we get, because we've got Light on here now as well. You know, Liv2's IDE driver, and that runs really well. You know, I'm getting insane amount, 4.7 meg per second or something. It was kind of handy that I blew this up by fitting this the wrong way around, because should you ever get in the situation where you get it the wrong way around, you've got some ideas on where to look. You know, the handy thing with this, and I mentioned this, there's a number of things I like about this board. I like the decoupling on it, I like the layout, the compactness, how it's managed to cram so much functionality in such a small area. But also, it's this attention to detail on the silk screen, all of the jumpers labelled. You know, they're a bit fiddly to find in some of them because they're spread out a bit, but you're always going to have that situation when you've compacted everything onto a board like this. But it's all of the silk screen markings here. When it blew up, it was really easy for me to just look at these things down here and go, hang on, voltages, or hang on, let's transpose it. I can see what's happened, voltages have gone into here. I looked at this chip, went, there's a little blemish on the top of it, and then it looks at all these connections here. What are they? You've got the odd ground, yeah, etc. But generally, things connected the wrong way around, you know, versus that side there, you won't get that issue. You won't get an issue. You could, in theory, you know, if ground's going into something that's an input or an output or something, yeah, it could, of course, kill something else connected up there. But logic says when you get this round the wrong way, and it's going to be a similar story on a zero slot, it's the voltages and grounds you want to look at, but the voltages in particular, your positive and negative voltages here, those are going to be the things that got fed into the wrong chip. So yeah, we ended up just swapping that. Of course, when I swapped that, it still didn't work, and I'm like, oh my god, what else has gone wrong? And I spent a while looking at the schematics, thinking about things, and then I just went back to basics. I thought, let's put it at the slowest clock speed. Still doesn't work. Let's disable half the RAM. Still doesn't work. Let's mess around with the E-clock. Still not working. Let's try it alongside a 68K and have the 68K's E-clock. Still wasn't working. It was only when I came to the IDE, I thought, let's disable the IDE. Boom, it booted. I'm like, hang on a minute. So it works when there's no IDE. And then I spent some time looking at the schematics going, what on the IDE could have been taken offence to the adverse, you know, adverse effect of it being round the wrong way? And I couldn't find anything, because everything on this here is actually on the 3.3 volt side. It's all buffered, yeah? He's done an incredible job buffering everything with these three chips. So that left me with a dilemma of how could this be a fault on the IDE? And I was thinking about this then. Could it be this? But again, none of the connections go here. So then I was thinking, well, maybe something shorted through to the other side of this and then killed the gate array. But then I'm thinking, well, if it was lower data bit related here, D01234, etc., you'd have wider problems. If something had killed something in there on the same data bits, you wouldn't be able to boot. So I was back to this again. So I took this out and I put it in the program. The first time I read it, it was zeros. It was all zeros, like that was wiped. So I programmed it again, put it back in, still wasn't working. And then I realised I had exactly the same issue that I have with these adapters, that when you push the chip in, it goes really flat. And then you have problems with the programmer. Programmer can't see the chip, and I have to lift it out until it's almost level with the socket, and then it would read and write it. And then when I thought, is that the same issue here? And I put that little shim underneath, there we go, that solved it. There are no problems with the solder points here. There's no problems with this socket bowing. The problem is, some of these sockets don't work very well with these types of chips. They do sink a bit lower, even though you've got the base underneath it. And in this case here, we've shimmed it up. But rambling aside, I hope you found that interesting. And yeah, we might do a follow-up video with future firmware, etc. If you'd like to build one of these yourself, see the links down below to the GitHub page. You could go away and, you know, get the Gerbers from there. Go away to somewhere like PCBWay or JLC PCBs. Get yourself a board and order up the bill of materials, you know, the different parts and things there. It's not that hard to build. The pitch on these and that were the hardest bits. Maybe that as well. The RAM wasn't too bad, although, well, yeah, the RAM's probably the same sort of pitch. Yeah, it was a bit fiddly, and everything is packed in there. So anyway, hopefully you found that interesting. I will catch you in the next video.